gravity? Is it a force? Is it a wave? On a quantum level, how does it even work? One thing is for sure, gravity is very weak, as far as physics can prove the weakest fundamental force. In my writings and theories, I refer to gravity as a wave, one of the three primordial waves, with sound and light being the other two. Though I lump gravity together with the other two waves, it is still in a category of its own. In my theories, all other waves and forces derive from sound and light waves, while gravity is the one force and wave that holds all together. According to general relativity, gravity is how space-time is affected. Let's say space-time is an elastic net containing physical reality. The sun is a large ball placed in the middle of the net. The ball would bend and sink the net where it was placed. Mercury, Venus, Earth, and so on would be much smaller balls placed on the net. Now, if we place the smaller balls on this net close to the large ball will pull them towards itself. This is the concept of general relativity. The extremely pliable net's depression from each ball placed on it forms gravity. According to this analogy, the extremely pliable net is space-time, and the balls are the celestial bodies that produces the gravity in space-time. In quantum theory, gravity leaves us with question marks. In the quantum world, where physical reality is the most fundamental, all particles are the process of excitations in particle fields. Basically, for every particle in existence, there is a field. These fields produce nothing until something excites them and a massless particle appears. The arousal of a field is the excitation that produces the no mass-having particle. Once the excitation stops, the particle no longer exists at that point, or it exists at another point where an excitation is taking place. All fields measure zero at rest, except for the Higgs field and neutrino field. The primary function of the Higgs field is to give mass to particles in the other fields. Without the Higgs field, we would not have the perceived physical reality we exist in today. Excitation produces particles in their given fields. The Higgs field then collects the particles together as a mass. The graviton is the hypothetical particle for gravity in quantum theory. However, the graviton is just that, hypothetical. The hunt for a fundamental particle for gravity continues. As aforementioned, gravity is the weakest force. I beg the question, is gravity a force? Does gravity have a veritable field which would bear the impression of the graviton particle? Or is gravity a backdrop? According to general relativity, the mass of a celestial body produces gravity, making an imprint on space-time, pulling objects towards it. In my theory, time is the measure of change and is relative to many things. Without action or change, there is no time. The action taking place to produce time has been in motion beyond any measure known to humankind. Is space-time and gravity the same? Is this the reason gravity appears to be an extremely weak force, and the graviton is the proverbial needle in a haystack? Here, LQG, or loop quantum gravity, would be the most fitting theory. Space and time woven together in finite loops in a continuous network may explain gravity and space-time as being the same. Loop quantum gravity can work together with string theory. I stick with my theory that all is conscious. I could have gone deeper into the rabbit hole of theories aforementioned, but I chose not to. When I speak of gravity, I use the term wave, and, in theory, this is possibly one with space-time. In theory, the primordial wave of gravity, with sound and light waves, produces all of reality as we perceive it. I will further elaborate on forces, Wave, producing disturbance on the equilibrium of source oneness in my next write-up.